Multi-level models involve actually modeling at different, as name says, at different levels of the subjects. So the highest modeling resolution is the subject itself, but the subject may belong to some community. The communities can belong to bigger communities, let's say counties, and so on and so forth. So there are different levels and different variables connected with different levels that account for the total variability and total modeling and enter into the comprehensive model. Typical example is random effect models that we are going to have one example. Imagine, for example, that you have the modeling something about school students, and at the student level, let's say growth or some educational growth that you model as linear regression. Xi could be time, for example, and that is subject related. And then you may have at school level, you may have different intercepts. So the students are coming from different levels, and that is another level of modeling. So why would you do this multi-level modeling? Of course, you may learn more about treatments and about responses in a more comprehensive way. You may borrow strength and make all data having influence at all different levels of the model. So it is simply information flowing nicely in the model. But ultimately, you will get better fitting models. The models that account for uncertainty at all different levels. Let me give you one example why that may be important. Imagine that you have Poisson regression and you have observations which are counts, and you decided to model these counts as Poisson with some parameter lambda I connected with individual yi. And then you decide to use log link, and this is how you model the lambda I based on the covariates x1 up to xk in this case. Now for Poisson, the mean and the variance are equal to rate parameter lambda. So what happens here, the expectation of your observation and the variance of your observation is lambda I. However, most of the time when you have real data and real counts, you may find that expectation is smaller than the variance. Not always, but it happens. So essentially, it tells you that Poisson model as is not good model, because if it is good model, then expectation and variance should be close to each other. So what you do, you add the so-called random effect to the list of the covariates, and that random effect would be centered at 0, but the variance may not be 0, and it could act as a sponge to collect the excess of variance into Xi, and then have these parameters, beta 1, beta 2, beta 0 up to beta k, better estimated. So usually in the case of this over dispersion, the random effect models are much better fitting models.